Hello everyone, welcome to this video on the 2D layouts or 2D matrix. So this video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store. So let's get started. So let's not take time to discuss on this topic, let's just dive into the problems directly. So these type of problems are coming up in the recent years of CAT. So let's take some sample problems at a very basic level so that you understand how to solve questions like this better. So this is basically talking about a square matrix n by n, that's a generic definition. It can be filled with digits from 0 to 9 such that no two adjacent cells have the same numeral. Two cells are called adjacent if they touch each other horizontally or vertically or diagonally. So if I have a cell like this, right, so the one next to it is an adjacent cell, to the top, to the bottom and to the left, all of them are adjacent. It is also considering the diagonally present ones like this and this. So all of these are considered to be adjacent for this thing, right? At the vertical level, horizontal level and the diagonally they are connected, so that's why all of them 6, right, are adjacent. So it says, so a cell in one of the 4 corners has 3 cells adjacent to it, right? If I'm talking about a matrix, this is the corner cell, so it has nothing over here, right? So it has only this diagonally and then vertically. So basically 3 cells, and a cell in the first or the last row or column which is not in the corner has 5 cells adjacent to it. So if I'm talking about a cell like this which is in the last row, let's assume this is the matrix, right? This is in the last row, so there's nothing here, leaving that I can have here, 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 here and here, right? 1, 2, 3, 4 and 5, right? That's what it is. And any other cell has 8 cells adjacent to it, which is this figure, right? If I'm talking about this, 2 on the vertical, 2 on the horizontal and then 1, 2, 3 and 4 on the diagonal. So basically there are 8 cells which are adjacent to the cell. That's the basic definition of this, adjacent cells. Now the question is, what is the minimum number of different numbers that are needed to fill a 3 by 3 square matrix? So let's talk about a 3 by 3 square matrix. Right, this is a 3 by 3 square matrix, 3 rows and 3 columns. The goal is that I have to use minimum number of numbers, different numbers, so that I can fill the entire matrix. The rule is obviously that no two adjacent cells have the same number. So let's say I start with 0 here. So I cannot put 0 here, here and here because they are all adjacent cells, right, to 0. Can I put it here? Yes, no issues with that because these two are not adjacent cells. If I have filled 0 here and 0 here, can I fill 0 here? No. 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 Can I fill 0 here? Yes. And again, this cell is not adjacent to any of these two cells. Can I fill 0 here now? No, because this is present, right? So now can I fill 0 here? Yes, again this is not adjacent, so I can fill. So I have tried to fill only one number in as many boxes as possible. Now what will I do? I'll try to fill the next digit, let's say 1. Right, can I fill 1 here? No, because it is diagonally connected, right? So it is not a possibility. Can I fill here? No. Can I fill here? No. But can I fill here? Yes. Because this is not adjacent to this cell, so these two are not adjacent. That's why I can fill. So I have filled with 1 in as many boxes as possible. Now I'll try to fill 2. If I fill 2 here, right, can I fill 2 here? No, because it is adjacent. Can I fill 2 here? Yes, it is not adjacent, right? Again, no issues with that. Now I am left with one cell which has to be a different number, 3, right? Because if I use 0 here, it is already adjacent to one of this. 1 is adjacent, 2 is also adjacent, so I have no choice. I have to come up with new numbers, so that is 3. So I have to use 0, 1, 2 and 3, that is 4 different numbers. Not necessarily this, I can also use 1, 5, 7, 9, any 4 numbers, right? It's just asking me to use different numbers. So the idea is to actually, when you are asked a question like this, try to fill one number in as many blocks as possible, then try to fill the remaining blocks with just one more number, and then try. So try to minimize your different number of numbers. If the question was asking what is the maximum number of different numerals that can be used to fill 3 by 3 matrix, it is 9, right? So I'll obviously fill like this, or 0 to 8 or anything, basically any 9, and obviously I'll try to fill with minimum number of repetitions happening, that is every number or digit is appearing only once. That's the goal if I'm trying to put maximum number of different numbers. If I am trying to put minimum number of different numbers, I'll try to put one digit repeating as many times as possible. Then if I have no choice, then I'll fill the remaining with one more digit with as many times as possible. Next, I keep doing that till I'm done with all the blocks, right? That's how you do this. So this is a simple example of 3 by 3. It will be more complicated once you see 4 by 4, 5 by 5, etc. But it's a good thing to practice so that you get used to larger ones. So now let's look at a different type. This is more focused on chessboard. It is still a 2D layout with 8 by 8 matrix. So they are defining a chessboard. A rook placed anywhere can attack another piece if the piece is present in the same row or in the same column, right? So if I have a piece here, let's say in the chessboard, this is a particular column, so I cannot have pieces here. It's in the same row. I cannot have any other piece. I mean, basically a rook can attack entire column and entire row. That's what it is saying, provided that there is no piece in between the path from the rook to that piece. Obviously, if I'm having my opponent piece here, right, let's say this is my own piece, right, my team, obviously I cannot attack this, right, even though it's on the same row, because there's something in between. That's what they're saying. Then they're saying the columns are labeled from A to H. So columns are basically, these are the columns, right? So I define this A, B, C and so on up to H. That's 8. And the rows are numbered from 1 to 8. And C5, for example, means if a piece is in C5, it's in the Cth column, that is here, this is the column, and row is 5th row, that is this row. So C1, C2, C3, C4 and C5 this is the piece that is C5 is referring to. This is the position of that piece when I refer to C5. Right, that's the basic definition they have given. This is normal definition of a chessboard actually. Suppose the rook is the only piece on the board and it is at a position D5. In how many positions can another piece be placed on the board such that it is safe from the attack of the rook? That's a very simple question. Definitely should pass and try it. Hope you have passed it and tried it. So let's see how it would look like. So we have actually constructed a chessboard like according to the definition they have given, like A, B, C, D, F, G, H and 1, 2, 3 for the rows. So this is C5, A1. They are saying the rook is in D5. So D5, this is where the rook is. So obviously rook can attack this and this, and this and this. So I cannot place my piece in any of these crosses, right? Obviously even here I cannot place because the rook is already sitting here. So there are altogether 8 by 8 matrix is 64. It will take you time to count 1, 2, 3, 4, 5 blah blah blah. Rather I would do 64 minus, I will eliminate all of these cross marks. There will be 8 in this and there will be 7. If I obviously 1, 2, 3, I am excluding this part because I am already counting this here. So that's 8 plus we will have 7. Right, so basically there are altogether 15 positions, right? All of these crosses together, if I sum it up, 8 plus 8 16, but this is counted twice, so it is 15. So 64 minus 15 would be 45. Sorry, 49. 8 plus 7 15, right? So it is 64 minus 15 is 49. So the answer is I can put in 49 pieces, right? It is like I can put 1 2 3 4 5 6 7 in this row, 7 slots, 7 slots, 7 slots, 7 slots. I cannot put anywhere here, 7 7 7. So like that I have 7 rows, so 7 7s are 49. That is also a way to look at, but anyways, that's how. So let's add a bit of complexity just for the discussion sake. Let's say there is one more piece that is my king here, okay? The rook and king are of the same team. Okay, let me, for that sake, let me write like this. Right, now if I am trying to figure out how many places can I, put opponent's king such that the game is not done. That is, the it's not the checkmate position. So the opponent king cannot be here, because this is our king. So opponent king cannot be sitting here, otherwise he will get killed. Opponent king cannot be here as well, because the rook will kill him. So he can use everything else, right? So this king, our king, is blocking 1, 2, 3, 4, 5 more slots for the opponent. Anyways, I know that because of the rook, 15 slots are blocked already in this board. Now this king is blocking another 5 slots, so that is altogether 20 slots are blocked. Plus I should also, sorry, king is 6 slots, right? So my bad, it's 21 slots. Why? Because the king is already sitting in 1. So the opponent king cannot sit here. 1, 2, 3, 4, 5 and 6. So altogether 15 slots are blocked by the rook, that is this, and then another 6 slots are blocked by our king. So 21 slots are blocked out of 64. So the opponent can sit in 64 minus 21 would be 43 slots. No, we can add complexity like this. This is still an easier question, but that's a good way to start getting used to this 2D layouts and matrix, right? So the chessboard situation, or we can create a new game where we have blocks like this and stick to the rules and play it. But it requires you to get used to imagine things and draw this diagram in 2 dimension and play around with it. Once you get used to doing solve questions like this, then you won't find it too difficult. So thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you can watch videos like this and also practice a lot of questions that would help you in your preparation. Also like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content and all the updates are shared over there, so don't miss that. Also like to this YouTube channel where you're watching this video. We're coming up with a lot of content and it will indeed help you to learn a lot from this channel, so don't miss that. Thank you and let's meet in the next video.